Hi there. Thank you for clicking on this practice set for roots of polynomials to kind of test what you learned in the previous lesson. Please like and subscribe if you find this video helpful. Drop a comment or question to engage, and check out the other videos and playlists that we have on the channel. As always, pause the video to work these problems on your own, then come back to check your work. Right, for numbers 1 through 3, hopefully you did not make this more than it should have been. This was just state how many roots the polynomial has. So you were simply looking for the degree, and then that is how many roots the polynomial has. So for this first one, we have a degree of 4, so there are 4 roots. Now this one might have tripped you up, okay? So we'll do a little bit of reasoning over here. If you were to graph this, okay, so here's my XY plane. This would be a horizontal line through y is equal to 3. And as you can tell from this, it does not appear to have any x-intercepts at all. So you might say, well, I don't see any roots on that. So it's going to be degree 0 or 0 roots. Here's the piece of information that hopefully will connect the dots there. This would be 3 times x to the 0, because we know that x to the 0 power is equal to 1. So 3x to the 0 would be 3 times 1, or 3, and we wouldn't bother writing it. So there actually is an exponent of 0 there, indicating that this one actually has 0 roots. Okay, so that one probably threw you a little bit. Sorry. All right, and the last one, this one is just simply out of order. And so the highest exponent is 3. So this one does have 3 roots. You were not asked to find the roots for any of these problems, so hopefully you did not do that. We always want to read the directions. It just said to state how many roots you would be looking for. Okay, so for 4 and 5, this is relying on the graph. And if you watched the lesson or you just came from the lesson, you know I said that a lot of the finding the roots of polynomials, like why is this a thing, why is this a skill, it comes from the days before there were graphing calculators. And so you would see something like the polynomial in number 4, and you wanted to sketch a graph, or you needed to sketch a graph. Well, to do that, you would study the end behavior, and then you would learn all these processes for finding these zeros or roots, x-intercepts and such. And then you would use that information to sketch the graph. With the advent of graphing technology, that is not something that we need to do. And so learning how to use the graph to identify them is a useful skill. So in number 4, you can see there that, I've graphed it. And then before I imported it over here, pasted it over here, I did highlight where those x-intercepts are. And so it looks like we have roots at -1, at 3, and at 6. And because it is a 3rd degree polynomial and I can see 3 roots, I know that that is all of the roots that I have. So if you were asked to identify all the roots, you would be done with this problem. Now for the next one is x to the 4th minus 16. So I know that we are looking for 4 roots, but this is asking us only for the real ones, which is good news because I don't have, some of those are not real. So I can see that there are 2 roots, x equals -2 and x equals 2, but there are also 2 more. Okay, because there are 4 total, and we have 2 of them. So I'm going to write here plus 2 more that are complex. Okay, and we know they have to be there. Now, later in this, like you might have noticed, like we are going to go and find them. And I do want you to take a look at this, because the graph of that has this parabola-y look to it. Like it sort of looks like a parabola, except the bottom of it down here looks like it's too flat to be a parabola. It is not flat, but it's flatter than what a parabola would be. So you can tell that even though that has a parabola-y look to it, it's not quite right. All right, now question 6 is an interesting one without doing any work or creating any graphs. So this is like a multiple choice skill thing. Which of the following has to be the roots for x to the third plus 2x squared plus 9x plus 18? So what we're going to do here is use what we know about the nature of polynomial roots, and we're going to play an elimination game. So because this is a cubic, okay, degree 3, we know we are looking for 3 roots. So our strategy is going to be eliminate anything that is not 3 roots. Okay, we know we're looking for 3 roots. So I am not picking A, and I'm not picking C. Okay, and remember that this is 2 different roots. That's x equals negative 3i and x equals 3i. So that's how we would write that, like plus or minus 3i. So the first one only has 1 root. Now you might say, well, what if it's 1 root with a multiplicity of 3? And that is potentially a problem. You want to read directions carefully and look to see if they would indicate the multiplicity. If it just says x equals negative 2 and you're being asked for the roots, I think that like it should say something like with a multiplicity of 3. Okay. Otherwise, I would assume they just mean x equals 2. Now, the other 2 have 3 root options. So here's the next thing that we are going to keep in mind, and that is complex roots always come in pairs. And so what we're going to do is eliminate anything without the pairs. Okay, and if you look at answer choice B, it's got this 1 rogue complex root there. I guess it's where it says x is equal to 3i, and there's nothing to go with it. So we have x equals negative 2, which is real, x equals 9, which is real, and then x equals 3i, which is not real. And we know that the complex ones always come in pairs. So that can't be it, which means this has to be my answer choice. And the point of that question is, instead of like diving into, oh my word, I have to solve this, I got to find the roots algebraically, or let me go to a graph and take a look at it. There's other pieces of information that you have that might be faster than doing either of those. So useful kind of question. All right, so for this one we've actually looked at. I think this is the 3rd time this one has showed up in the problem set. And first we were just asked how many roots does it have. Then we were asked, like, use a graph to find the real ones, and we established, oh, like, there are 2 complex ones, and now we have to find the complex ones. So we've got 2 of our 4 roots already. We know that x is equal to 2 and x is equal to negative 2. Now, to solve this for the other roots, what I am going to do is I am going to factor it because that's an option for me. And I had a student the other day. We were working on something, not this, but we were working on something, and she just said, well, how was I supposed to know that? And I said to her, well, you're not necessarily supposed to know it like when you first look at it. You know it by asking questions, you know it by watching a review video, you know it by like fighting with a problem and then having somebody like show you like, hey, here's a way you can do it. And this is one of those things that with years of experience, like looking at these, you begin to see this one is factorable. So what we have here is x to the 4th is really x squared, and 16 is 4 squared. So we're looking at a difference of squares. We have 2 things that are squared and we're subtracting them. Now, a trick of the trade to clean it up. Some people will say u is equal to x squared. So they'll do this thing where they take a u and they just put it in place of something yuckier. And they do that to clean it up visually because the x squared square, there's a lot of squares floating around in there. And it's just easier to look at it with a u. Okay, that's all that is. And then they would go ahead and factor it. So this is u plus 4, u minus 4. And then they'll go ahead and put the x squared back once they're done doing whatever was messy. Now we can use the zero product property. So we have x squared plus 4 could be equal to 0, and x squared minus 4 is equal to 0. This is the one that's going to generate the real roots. Okay, that one right there. So we could do this by adding 4 to both sides. So we'll just add 4, and then we can take the square root. And when you take the square root, remember it is plus or minus. So we end up with x is plus or minus 2, which matches what we have up here that we got from the graph. The other one, x squared plus 4 equals 0. This is the one that's going to give us the complex roots. And if we go through the same strategy there, where we end up with like x squared equals negative 4, we take the square root. And so the square root of negative 4 is 2i, and there are my other two roots. So my other two roots are 2i and negative 2i, and that brings us up to the 4 roots. Now, that is, what was I going to say about it? That one algebraically wasn't too bad because it was factorable. But not every one of these would be factorable. So because this is a fairly short video, I'm going to show you maybe the longer way to do this, not because it's necessary for this problem, but because some of you that are watching this video, you might be in a class where your teachers are giving you some of the messier ones, and I want to show you how that works. Now, without getting into the rational roots theorem, where you would do find all your candidates for possible real roots, we're going to jump to use a graphing calculator to find the real ones. Then what you do is you do polynomial division. Now, I prefer to do polynomial division with an area model, but for the sake of expediency, I am going to use synthetic division in this video. Now, remember that polynomial x to the 4th minus 16, that you have all these zeros in here. When you are doing polynomial division of any sort, you do need to remember that. Okay, and I'm going to go ahead and divide by the 2. So I'm going to drop the 1, and then what we do is we multiply, and then we add, and then we multiply, and then we add, and then we multiply, and then we add, and then we multiply, and then we add, and it divides evenly, which I knew was going to happen because I knew that 2 was a 0. And my reduced polynomial is 1x to the 3rd plus 2x squared plus 4x plus 8. So what this process is, this is called reducing your polynomial. So we go from a quartic down to a cubic, but I don't really have any other tools to use until I get down to a quadratic. Okay, and so what we're going to do is repeat that process with the smaller polynomial, but we've got to use the other root that we had. So if I use the 2, now I got to go use the negative 2. Drop the first term, we multiply, and then we add, and then we multiply, and then we add, and then we multiply, and then we add. Okay, and once again, it divides evenly, and my polynomial is x squared plus 0x plus 4, which is x squared plus 4. And now I can go ahead. You'll notice I am in the same spot here that I was over here when I got the x squared plus 4. And now you can use the quadratic formula, or you can do what we did. And that is how you use the synthetic or polynomial division to get there. And you would have to do that in something that had a much, much messier look to it like it wasn't factorable. Like you would have to graph it and then slowly go through all that polynomial division, like getting it smaller and smaller and smaller until you had something else you could do with it. All right. Now this last one, find all the roots of the polynomial. Now I think I intended for this one to be one of those kind of problems where you would use the graph, you would find, a real one, and then you would do that polynomial division. And then when I was doing this earlier, I was like, oh yeah, go me. So we go to graph it. And what we see is we see two x-intercepts. So I see the -5 and I see the 3. Now, remember, we're looking for 3 roots. So I have x equals -5 and I have x equals 3, which appears to only be 2 roots. But notice that this one is bouncing, and when it's bouncing, it means it has even multiplicity. So since I'm looking for 3 roots and I only have 2, this one must count twice. And so I'm going to put like a ×2 there, basically saying, hey, this one has multiplicity of 2. Now, you can also use this to factor it. So we know we've got all of them. So we know that if like x equals -5 is a root or 0, then x plus 5 must have been a factor. And if x equals 3 is a 0, then x minus 3 must have been a factor, and another x minus 3. And so you can actually use this to go back and get the factorization based off your relationships between the factors and the roots. All right, that is it. So thank you for hanging with me. Don't forget to like and subscribe for more math help. Drop a comment or question. Let me know what you'd like to see on the channel, and check out some of the other videos and playlists. We have multiple choice help, Desmos help, algebra tiles help, and more. I hope to see you in a future video.